The topic of our research is predicting the concentration of carbon monoxide in the air based on the ultraviolet index using artificial intelligence methods. So you know that air pollution is one of the most present in environment in US. So carbon monoxide is one of the most dangerous pollutants due to its toxic effects. In Chernobyl, the main source is automobile transport, and therefore it is important to predict its concentration for operating monitoring. So, based on the previous observations, we formed a hypothesis. So there is an inverse relationship between the UV index and CO levels. So under the influence of solar radiation, CO is oxidized, and this is reflected in the change in this daily profile. So in Chernobyl, up to 37.5% of IV samples exceeded permissible CO level due to automobile emissions, for example. And carbon monoxide exposure can lead to serious, for example, health risk, yes? And for example, integrate air quality monitoring station allows for accurate CO level assessment. For example, the use of machine learning algorithm improves prediction capabilities for effective air quality management. The research use real data from the Air Fresh public eco station. For example, this air station models operate in real time, measuring the concentration of K pollutants. Therefore, one of the stations was installed on the territory of Chernobyl Ivan Paluy National Technical University in cooperation with the EcoCity project. In addition, we have developed a portable station of measuring the UV index level based on the Arduino platform and ultraviolet radiation sensor. When monitoring data from both stations, it was found that the level of CO increasing during period of high traffic load and decrease during the intense solar radiation. Thus, during the daytime, when the UV index is high, the concentration of carbon monoxide decrease, which confirm the existence of the inverse relationship between UV index and CO. So we can say that carbon monoxide is oxidized by ultraviolet radiation, leading to a decrease in its atmosphere level. So this oxidate process is clear to improving air, for example, quality. So UV index radiation intensity is heaviest during the afternoon, which corresponds to the lowest CO concentration, for example. So we can see that during peak UV times, or for example, March 18, yes, CO level decreased. This demonstrated an inverse relationship between the UV index and the carbon monoxide concentration. So for predict, we use several models, for example, linear regression, polynomial, exponential, and neural network. The goal was to find the model with the best generalization and accuracy. So the analysis our investigation, yes, for prediction, we use this model and obtain some results. So the analysis of heat maps showed a clear trend. For example, during a period of high UV index during the day, yes, you can see a decrease in CO levels is observed. For example, you can see March 17, yes, for example, afternoon, when UV index have some numbers, yes, and you can see that CO is decreased, yes. And for example, at night, when UV index is 0, yes, CO concentration, you can see remains constantly high. So this confirms that the increased relationship between the intensity of ultraviolet radiation and the level of carbon monoxide in the air. So here you can see that we visualized the relationship between UV and CO. For example, blue color indicates a high UV index and, for example, red, yes, high CO level. It can be seen that an increase in UV index is accompanied by a decrease in CO, especially during the daytime. So here you can see that the mathematical analysis of the results, yes, confirms that neural network better describes nonlinear relationship between parameters. This is especially important to environment, for example, monitoring tasks, whereas classific models are often insufficient, for example, yes. And here you can see the results. For example, we evaluate the results during coefficient of deterministic, yes. For example, mean square error and MAP, yes. And we can see that neural network shows the best value of determination coefficient, while the other models give worse accuracy rate, yes. The map of neural network was also the lowest, and for about 8.58%. So we can say that this approach can be used for early warning, yes, of air quality deterioration, for example. Our work also take into account the experiments of other authors who have, for example, used machine learning methods, yes, to predict other pollutions, yes. This provides the advisable of implementing AI in the environment monitoring. So we have some summaries that the neural networks demonstrate the effectiveness in predicting CO levels from UV index data. And a clean inverse relationship, for example, exists between UV intensity and CO concentration. And this relationship is, for example, crucial for effective air quality management strategies. So the neural network-based model effectively predicts CO concentration from UV. And it is promising tool for environment monitoring in our native town, yes, Chernobyl. So thank you very much for your attention.